Why do seismic waves make buildings shake? Imagine standing on the ground during an earthquake and feeling the earth suddenly tremble beneath your feet. That shaking is caused by seismic waves traveling through the Earth's crust. These waves are energy released when stress along faults in the Earth's crust suddenly breaks. When this happens, it creates waves that move through the ground, kind of like ripples spreading across a pond. These waves carry energy from the earthquake's focus, or the point where the fault slips, to the surface. There are three main types of seismic waves. First are the primary waves, also called P waves. These are the fastest seismic waves and move the ground back and forth in the same direction they are traveling. They cause the ground to compress and stretch, which can make the ground move up and down or side to side. Next are the secondary waves, or S waves. These are slower than P waves and move the ground perpendicular to their direction. They produce strong horizontal shaking and are usually more damaging because they shake the ground side to side. Lastly, surface waves, known as Rayleigh waves, travel along the Earth's surface. They cause both vertical and horizontal ground motion and tend to have larger amplitudes, meaning they shake more intensely and for longer periods near the earthquake's epicenter. When these seismic waves reach the ground beneath buildings, they transfer their energy to the structures. Since buildings are usually stiff and rigid, they respond by vibrating. The amount of shaking depends on several factors, including how strong the earthquake is, how close the building is to the fault, the type of soil, and how the building was designed or built. For example, soft soils can amplify seismic waves, making buildings shake even more. Most buildings are designed to resist vertical forces like gravity, but they are less prepared for horizontal forces caused by seismic waves. This lateral shaking can cause structural elements to sway, bend, or even break if the building isn't properly reinforced. That's why seismic retrofitting is so important. It involves strengthening existing buildings with features like shear walls, which help distribute lateral forces evenly. Base isolators can be added to allow buildings to move independently of ground motion, reducing the energy transferred to the structure. Seismic dampers are also used to absorb vibrational energy and lessen the shaking. In the end, seismic waves make buildings shake because they transfer energy through the ground, causing it and anything on it to vibrate. The more we understand these waves and how they move, the better we can prepare. Installing seismic retrofitting measures and early warning systems helps protect lives and property by reducing the damage caused by these waves. So, next time you hear about an earthquake, remember it's the energy from seismic waves that's making everything around you shake.